You see them everywhere now, right? Those electric vehicles just silently cruising down the street. It feels like the future is already here. And for most of us, that's kind of where the thought process stops. But what happens when that super quiet, high tech future breaks down? Well, it turns out fixing one of these things, that's a whole other ballgame.
Yeah, we all get how to plug them in and charge them up, but what about actually fixing them? That's where things get interesting, because we're talking way less about oily wrenches and greasy hands and a lot more about managing some seriously powerful, high stakes tech. So, to really get a grip on the challenge here, we've got to first appreciate just how different these cars are under the hood. And trust me, it goes way, way deeper than just pulling out a gas tank and dropping in a battery pack.
Okay, so first things first. The term EV gets thrown around a lot, but it's not just one type of car. It's actually a whole spectrum of different technologies. You've got your fully electric vehicles, sure, but then there are plug-in hybrids, regular hybrids, even these things called microhybrids, and fuel cell vehicles. And guess what? Each one is its own unique puzzle that needs its own special know-how. And that really gets to the heart of it. We're literally leaving behind the entire world of pistons and oil changes. We're stepping into a new era of, high voltage batteries, powerful electric motors, and some seriously complex power electronics that have to manage every bit of that energy. It's like we're learning a completely new anatomy for the automobile.
And right at the center of this new anatomy, we find the single biggest game changer for anyone who has to work on these cars: the high voltage heart of the vehicle. Now, when I say high voltage, I don't just mean it's got a bit more juice. In the auto industry, that's a formal technical classification. It means a level of electrical power that is seriously, genuinely dangerous, and, well, it demands a whole new set of rules and a massive amount of respect.
So, how high are we talking exactly? Well, a lot of EVs are running on systems that are 400 volts, sometimes even higher. To put that in perspective, the regular old battery in your gas car, that's just 12 volts. So this isn't just a little step up. It is a monumental leap in raw power.
Think about that for a second. We're basically putting industrial-grade electricity on wheels and driving it down the same roads you and I use every day. That single fact right there is the foundation for every single piece of specialized training and every safety procedure an EV tech has to master.
And all that power, it's great for performance, right? That instant acceleration is amazing. But it also brings a whole new set of hidden dangers to the table. Dangers that just don't exist in a gas-powered car. And managing those dangers, that is the absolute core of an EV technician's job. All right, let's talk about the first one, the one you've probably seen in the news: fire. See, when a lithium-ion battery pack goes up, it's not a normal fire. It actually creates its own oxygen as it burns. This kicks off a nasty chain reaction called thermal runaway, which makes these fires unbelievably intense and incredibly hard to extinguish. Okay, next up is something called an arc flash. It's a type of electrical explosion. It's violent. It can happen if a technician just accidentally drops a metal tool and it shorts out a high voltage connection. We're talking a blinding flash of light, scorching heat, and a pressure wave so powerful it can throw a person across a room. Then you've got chemical exposure. Inside those big battery packs, there's a cocktail of pretty hazardous chemicals. If a battery gets damaged in an accident or something, technicians have to be totally prepared to handle leaks and potential exposure to stuff that can be corrosive or even toxic. And maybe the scariest one of all, because you can't see it, is the high voltage itself. A gas engine, it's loud, it vibrates, you know when it's on. But a high voltage system, it can be fully energized, totally live, and absolutely deadly without making a single sound. It gives you no warning. It's a completely silent, invisible threat. And here's the kicker. These dangers aren't just for the technician in the repair shop. No way. A car crash, or even just something going wrong while it's charging, can expose anyone to these exact same risks. We're talking drivers, passengers, and especially the first responders arriving on the scene. So, with all these crazy risks, you're probably wondering, how on earth can anyone work on these cars safely? Well, that's where the playbook comes in. There's a super strict set of procedures and protocols that are all designed to take that danger and manage it. The very first rule of that playbook is simple: identification. Technicians are trained to instantly, without a second thought, spot the two big warning signs of high voltage.
First, that bright, unmistakable orange sheathing on all the high-energy cables. And second, the standardized warning symbols you'll see plastered on the components themselves. Now, the car manufacturers, they build in a ton of safety layers too. You've got what's called direct protection. That's the physical stuff you can see and touch, like thick insulation and heavy-duty enclosures. But then there's the indirect protection, which is all the smart stuff working behind the scenes. Think fuses, circuit breakers, and sophisticated monitoring systems that are constantly on the lookout for any little fault. But out of everything, the single most critical procedure, the one you absolutely cannot skip, is the isolation procedure. Basically, the power down. Before a wrench even comes near the car, a tech has to follow a very specific sequence. You've got to follow the manufacturer's shutdown process, then physically disconnect the high-voltage battery with a service plug. Then you wait. You have to let all the stored energy in the system discharge. And the last step, the most important one, you test it. You take a multimeter and you verify that there is zero, and I mean zero, voltage left. You never, ever assume it's safe. You prove it.
So when you put it all together, the incredibly complex tech, those invisible dangers we talked about, the super strict safety protocols, it means the person working on your EV is so much more than what we think of as a traditional mechanic. They really are a new breed of technician, a highly skilled specialist. And having that expertise isn't just about fixing a car, it's a huge public safety issue. Because if an EV gets in a crash, the risk isn't just contained to the car. It extends to the people inside, to the paramedics and firefighters who show up, to the tow truck driver who has to clear the scene, and even to onlookers standing nearby. Everyone involved has to have a whole new level of awareness.
You know, the toolbox for a modern tech looks completely different now. It's not just about having the right size wrench anymore. It's about having specially insulated tools, high-voltage safety gloves, face shields, all kinds of personal protective equipment. But honestly, the most important tool of all, it's continuous training, because this technology is changing so fast you have to constantly be learning just to keep up.
And that knowledge can't just stay in the repair shop. It has to spread out. Emergency crews need to know how to safely cut someone out of a crashed EV without hitting a high-voltage line. Towing companies need brand new protocols for handling these vehicles. It's really a whole ecosystem of different professions that all have to adapt to this new electric world.
Which kind of leaves us with one big question to think about. The technology for these amazing electric cars, it's here. It's getting better every single day. But the real question is, are we building up the human side of it, the skilled, trained, and ready technicians fast enough to actually support the incredible revolution that's already happening on our roads?